Hello all, and welcome to your last lesson before spring break. As you hopefully have seen in the calendar, I just want to give you a day to catch up on some missing assignments so that you don't feel like you have to do a million things over break. So you've got an extra day during this week just to catch up and do what you can. You are going to have this lesson from finishing up section 5.4, so get yourself ready for notes and we're going to get started. So here we're going to look at integrals in word problems. We're going to start by going over a couple of things so you can pick out the different vocabulary pieces. So here, a particle is moving along a line, so its velocity at time t is v of t equals t squared minus t minus 6, where v, velocity, is measured in meters per second. What do the following integrals represent? So if you remember, integrals are the antiderivatives, and one thing I would hope that you do recall is that if you have the position function f of x, then velocity function of that same position is the first derivative, and acceleration is the second derivative. So these are all connected. Now if we have the velocity and we're integrating, that's the antiderivative, so that will give us back our placement. So I'm going to actually jump to part B here for a second, is that the integral of velocity is the position function. Now if we put bounds on the position function, this is what's called the displacement. And displacement is the difference in the position between, and you just have to look at the bounds, in this case, t equals 0 and t equals 4. It might also be like in the first 4 seconds. Now, displacement is different than total distance traveled, because you can imagine a particle might start here, go all the way here, come back. The displacement's this distance, but the total distance traveled would be all the way to here plus all the way back. So we'll look at some of those different options between displacement and distance when we actually are doing the math. So for C, what are the units of the integral of v of t? Well, since we know that velocity is measured in meters per second, so velocity here, the unit is meters per second. And you can even think about t as time, so when I multiply by my time unit, which is seconds again, cancels out, the position that we're left with is just meters. Whoop. So that's always going to be the same as whatever the distance portion is there. So find the displacement of the particle in the first 4 seconds. So that's going to be part A, so from 0 to 4 of, in this case, t squared minus t minus 6 dt. Now again, first step we're going to do is find our antiderivative of these terms separately. So 1/3 t to the third minus 1/2 t squared minus 6t. We're not having a plus c because we have bounds. 0 to 4. So then we plug those in. So 1/3 times 4 cubed minus 1/2. 4 squared minus 6 times 4 minus, when you plug in 0 to all of these terms, 0, 0, and 0, you know you're going to end up with that. So it's just fine to say, minus 0, and just work with that first bound, which would be 64 over 3 minus 16 over 2 minus 24, which equals negative 32 over 3. So that's the total displacement. So what this means, if I look at the graph of this function, is that between 0 and 4, we're mostly dealing with terms underneath our bounds. Underneath the axis. So this would be a rough sketch where we have our y-intercept at -6. And so the area under the curve here is a lot of negative area. And if I use, this is t squared minus t minus 6. If I factor that, that would be t minus 3t plus 2, which tells me that my roots are at -2 and +3. So then 4, I only have this little bit of area here that would be positive between 0 and 4. And that's why we end up with a negative displacement. We're traveling backwards for most of it, and then we go forwards a little bit. Negative direction, positive direction. So if we want to find the total distance traveled, we have two options. We can do this by hand by splitting it apart into 2 sets and say, all right, I want to find from 0 to 3 of my velocity, and I know that that's going to be negative, so I'm going to multiply it by -1, and I'm going to add from 3 to 4 of my velocity function. So I can do it like this. I also want to show that you actually can do all of these on your calculator, and the way I would do this is this here, not 0 to 4 for the whole thing. We could say find the absolute value of the velocity, because absolute value will already make it all positive. Now, you can do this on your calculator by saying, I'm going to go to the math button. So if you're using a TI-83, TI-84, you're going to see nderiv as an option. This is using your derivatives on your calculator. And you're going to see fnint. So this is integrals on your calculator. In this case, we're looking at an integral, so click on that one. And most of you will then get something that looks like an integral. Now, if you don't, please set up a Zoom meeting. And if you have a different type of calculator, you want to figure that out, please do that. So here, you're going to want to just put in your absolute value signs. So type in your bounds, 0 to 4, and then for your calculators, some of them will be ABS, some of them will be lines. In either case, the way you find this is you go to Math, and then you scroll across to Number, and this will be an option that you can pick. And then you type in the velocity function, which in this case, you're probably using the x variable. That's fine. X squared minus x minus 6. And then D, and you just tell it what variable you want to use. And click enter, and you will get 16.3 repeating. So, absolutely, you can do it on your calculator to check your answer. I also want you to practice doing the work by hand. If you have any questions, please let me know, and I'll be happy to help you work through anything you're stuck on. Have a fantastic break if I don't hear from you before then, and I will talk to you soon.